Well, I was just going to do a video there on the mean proportional. So what I have here is a rectangle 9 by 4, and the aim is kind of to make this into a square that contains the same area. So the area we're working with is 9 by 4, which is 36, and to find the sides, just find the square root of that. 36 is equal to 6. So 6 is going to be the length of the sides of the square. So into the construction now, I'm just going to extend this line, the top of the rectangle. Extend it out good and far, just because we'll probably be using it later. So it's just better to have it done than have to go measuring again. So I'll just use the compass there from this top point of the rectangle and measure down to the side. You can see there. Then I'll just swing this up to meet my extended line. And what I have here now essentially is a diameter. So that's going to be the diameter of our circle. So obviously we need a center point to draw the circle. So I'll just do that by bisecting the line. Wherever it's at there. Now, so I can just draw a center point from that. Now, I'll just show you so you can see that these are equal now. 6.5 and 6.5. Right, so now we can just draw the circumference of our circle. Now from here we can extend this line up just until it meets the circumference. So now you can see it's meeting there, and if I show you, you can see that's going to be actually one of the sides of the square. So that's 6, which is exactly what we wanted. Now from here I can go about this a number of ways. I can use my set squares for t-square. But I'm just going to use my compass and take my measurement. And you can mark it there. Mark it in here as well. Now, so I'm just going to heavy in these just so you can see them. So I'll heavy in this one down here first. Now, so that's our square, and that's going to be 6 and 6 and 36 in the middle. So this whole thing is based on the concept of similar triangles. So if I mark these up, make this A, B, C and D, make sure it's this point, not that one, I can see that the triangle of, marking my lines first maybe. So I can see that the triangle ABC is similar to the triangle BCD. And how I know this is basically through the maths of the angles. So if I were to call this 30 degrees here, well, I know then that this is going to be 90, and that would leave me then with 60, because 90 and 30 is 120, and 120 need 60 then to reach 180, which is the size of the interior angles of a triangle. And obviously then this side here is going to be 90, and because this point here is on the circumference of a circle, and we know then that that's going to be 90 degrees, so 60 and 30 is going to give it 90, and then we have 30, 90, and again this will be 60. So you can see then that the two triangles are similar. If I were to sketch them out here a bit lower, see all the angles add up, so A, B, C, and then C, B, D. Obviously if it was to draw them properly, you could see the triangles look the exact same, only a smaller version. So that's the mean proportional there. I hope you find that helpful.